linear correlation coefficient. We should be able to compute and interpret the linear correlation coefficient. We shall also be able to determine whether a linear relation exists between two variables. Okay, the one in x-axis and the one in y-axis. The variable in x-axis we shall call the explanatory variable. The variable in y-axis we shall call the response variable. And we shall be able to difference between correlation and causation. All right, so I advise you to read the notes. Read the notes. Make sure you read these notes or PowerPoint, whichever one you like to read, the notes or the PowerPoints. Okay, so what do we call the response variable? If I draw an L graph in the first quadrant, the response variable is x. The predictor variable, actually the response variable, the predictor variable is x, the response variable is y. So y is the response variable, x is the predictor variable. You can also call x the explanatory variable. So x, the horizontal axis, is the explanatory or predictor variable, while the y, which is the vertical axis, is called the response variable. All right, so we are going to use data here to practice drawing a scatter plot. So we're going to get a calculator and draw a scatter plot of this data. But before we draw the scatter plots, let's first of all go and see the kinds of scatter plots that we have. If I have a scatter plot that all the polar points are going to the right, you know that if I draw a line here, it's going to be, the line is going to be a linear equation or a graph, a linear graph that has a positive slope. So we shall say that this is linear. All the points are not on the line, so this will be called the high positive linear relationship. So the relationship between this explanatory variable and response variable, we shall say it is high positive linear relationship. High positive linear relationship. And this one, if I look at this, I eyeball this, the line that will fit the scatter plot will be a line with a negative slope. So this is going to be high negative. We shall say that's a high negative linear relationship. High negative linear relationship between the explanatory variable and response variable. High negative. Why? Why do I say negative? Because the line of best fit, is going to have a negative slope. High negative linear relationship. That is the kind of relationship that the x-axis has the y-axis, and x-axis, remember, is called the explanatory variable. All right. Now, let's go to the next one. Okay, this is non-linear. It is not a linear relationship because I can see that the graph has it looks like a quadratic equation. This one looks like a parabola with a maximum point. So this is not linear. We're not going to see linear. And this one is also not linear because it looks like a cubic equation, so it's not linear. Also, in this particular question, we shall say there is no linear relationship because I can't even find out whether it has it doesn't show whether it has a positive or negative or So the important thing is there's no linear relationship. There's no linear relationship. So whenever you draw a scatter plot, you have to be able to interpret the kind of relationship between predictor variable and the response variable. Interpret the kind of relationship between the predictor. Now, the next one, let's go back and see. So we shall positive association is the same as positive relationship. Negative association is negative relationship. The linear correlation coefficient of Pearson product moment correlation is P, is called P for, we call it rho. This is for population. And if it is a sample, we will use R. So sample is going to be R, and rho is for population. So we're not going to see rho a lot. So properties of, these are the properties of rho or R. The linear correlation coefficient is always between 0 and 1. So I can write an equation R here. I have between -1 and 1. So 1 here is less than or equal to -1. In other words, I can draw a number line and I will say that the coefficient of correlation ranges between 1 and -1, or from -1 to 1. So in other words, the coefficient of correlation can be -1, a -0.9, -0.5, and so on between here and here. Okay, the linear correlation coefficient is not allowed to be greater than 1. It's also not allowed to be less than 1. If the linear correlation coefficient is +1, then all the points are on the line. Then all the points are on the line. If the linear correlation coefficient are on the line, then all the points are on the line. So we call it perfect positive linear relationship. Whenever R is equal to 1, we say we have a perfect positive linear relationship. When R is equal to +1, but if R is -1, we will have a perfect negative. In perfect negative linear relationship, the slope is negative and all the points are on the line. So anytime all the points are on the line, they are collinear, the points are collinear, then we say that we have a perfect negative linear relationship. Okay, so if we're just coming in, we are discussing the properties of coefficient of correlation. R is for statistic, rho is for parameter. The R is between -1 and 1. Okay. All right, so the closer R is to +1, we say positive association or high positive linear relationship. The closer that it is to -1, we say high negative or strong negative. Okay, so if R is equal to 0, then there's no linear relationship. If R is equal to 0, there is no linear relationship. Okay, so let's go back to the next, go to the next equation. So we're going to the next graph here. So we're in this particular question here, this is perfect positive linear relationships, all the points on the line. Therefore, R is equal to 1. This is strong positive linear relationship. Well, this is just positive linear relationship. This is perfect negative linear relationship. This is strong negative linear relationship. This one is just negative. Well, this one is, there is no linear relationship. You see, because it's scattered, we don't have any, it doesn't have any direction. So no linear relationship. And right here, there's no linear relationship. Okay, so there is no linear relationship in this one, because actually it looks like it is a quadratic. Okay. So this is how you can plot the point. You can construct a high positive or how you can construct it. We're going to do an example right now. So we are going to actually do an example. So let's get now we have critical values here. Very soon we shall explain what critical values are. But for now, these are called critical values. So for now, I am going to get a question, and we find, okay, so we find the linear relationship of that data. So let's get a question. Okay, let's go back and get a question so we can practice. So we are going to get put this question in our calculator. Yeah, so this is X, which drilling begins, X, and Y is in minutes. Okay, so I will pull up my calculator. Pull my calculator up, and then drilling is going to be in L1. So I'm going to turn my calculator on, clear, go back to start, edit, and I'm going to clear L1, actually clear L3, I don't need it. Also clear L2 because I don't need it. Also clear L3 because I don't need it. All right, then in L1, I will type in the drilling in feet. And the first one is 35, so 35, enter, 50, 75, 95, 120, 130, 145, 155, okay, so after 155, there are more down here. All right, so after 155, we have 160, 160, 175, 185, 190. Okay, so there are 12 of them. I am going to go to L2 and enter the response variable. So I'm going to L2 to enter the response variable. So now, so I'm going to L2 to enter the response variable. Okay. And the number one, which means 5.88 is associated with 35. So 5.88, enter. 5.99, enter. 6.74, enter. 6.1, enter. 7.47 and 47, enter. 6.93, 6.93, 6.42, 7.97. All right, so there are some more numbers. I have to arrow up and get that. Arrow down, I mean. Okay, so the next number is 7.92, 7.62, 6.8, and 7.9. Okay, all right. So I can see that both of them are the same number. They have to be on the same horizontal level. So the next thing now is to find, I'm looking for the scatter plot first. So you have to watch it. This is our first time doing scatter plots. So second, start plot, and then I'll select plot 1. I'm doing scatter plot. So the first statistical plot is 1. I'm doing a scatter plot. So the first one, doing scatter plot, and scatter plot is number 1. So I'm going to select number 1. I'm select that, and I'm going to arrow down. My calculator is asking me, where is your predictor variable? Where is your predictor variable or explanatory variable? It's in L1. So I have to make sure I tell my calculator that it's in L1. And it's asking me right now, what is my response variable? My response variable is in L2. Okay, so I have put in all the things I need. I can zoom 9 now. If I click zoom 9 and this argument comes out, remember you have to second quit, then zoom 9 on the main screen. Okay, well, I'm zooming 9 on the main screen. I didn't see everything, so I have to do it again. I did zoom 9 on the main screen and I saw all the plots. They are scattered. They are not on the same line. Therefore, they are not on the same line. They are scattered. But I can actually see that this scatter plot, if I place a line of best fit there, the line of best fit will be going to the right. The line of best fit will be going to the right. So what I'm going to do right now, so this is how the scatter plot is. And I can now see when I eyeball the scatter plot, I know there's a high positive linear relationship between the explanatory variable and response variable. But that's not going to be the only thing they ask me to do. They might actually ask me to find R. Okay, so if I have to find R, the first thing I want to do is go to my mode, arrow to float, and make sure that I put float to 3. I want 3 decimal places only. So I'm telling my calculator that I need 3 decimal places. And now, before I find R, I want to change the float to 3, so 3 decimal places. And also, I want to turn what is called diagnostic. Turn diagnostic on. So I go to second catalog, second 0, and I'm looking for diagnostic on D. So I arrow down, diagnostic on, arrow down and look for diagnostic on. See, diagnostic on is right there. And this is diagnostic on. I haven't turned it on, so I can just click enter. So it is on. Okay, so now I can tell my calculator that I want to do a linear regression analysis. And how do I tell my calculator? Okay, I can just zoom 9 again, zoom 9, and I see the scatter plot again, But this time I want to tell my calculator that I want to draw a linear graph. So start, arrow to calc. I'm doing a linear equation. There are two kinds of linear equation. The first kind is where A is the slope and B is the y-intercept. That's another one. Number 8 is also a linear equation where B is the slope and A is the y-intercept. But I'm choosing number 4 though, because it looks like a. And then I'm choosing number 4 and I'm doing a linear relationship between my explanatory variable and response variable. And then it's asking me where is my X list. My X list is in L1, don't forget. My Y list is in L2. My predictor is in L1. My response is in L2. It's asking me if I have frequency. No. So it's asking me this time, do you want to store your equation in one of the functions? Yes. So you need to see this. Make sure you remember it. Vars, y-vars, function y1. If I want to tell my calculator that I want to store the equation in y1, then I'll calculate. I'm going to calculate. And I have everything I need. The equation. I can now write the equation of this. So I am ready to write the equation of the regression equation. And by the way, they told me to find the coefficient of correlation. So the coefficient of correlation is slightly greater. Well, it is greater than 0.5. Therefore, we shall say there's a high positive linear relationship between the predictor variable and response variable. R squared is the coefficient of determination. We will come over there. So right now I am going to write the equation of this graph. I already know the R. So the equation is in slope-intercept form. Y is equal to A in that equation is 0.012x. Then my y-intercept is 5.52 plus 5.527, 5.527. So that is the equation. That is the equation. And when I go to y1, I will see this equation again. And the coefficient of correlation, R, is 0.77. I can say it is 77%. 7.2%, and coefficient of determination is 0.597. So I could be told to find the coefficient of correlation and coefficient of determination. And that the method I use now is how I will find the coefficient of correlation and coefficient of determination. Let me go back to my equation. I'll go back to y1. Go back. And I want you to see that this is what I had. If I go to y equals, it gives me the same equation because I told my calculator to store the equation in y1. I told my calculator to store the equation in y1. That's why it is there. Okay, so I have found the equation, the regression equation they asked me to find, and I see that the slope is positive. Because the slope of the equation is positive, we shall say there's a high positive linear relationship. But what actually prompts me to say high? I will say high because the coefficient of correlation is 77%. So that's a high positive linear relationship between X and Y. Okay, let me go ahead and draw the, I'm now going to go ahead and draw the equation. So I am going to draw that equation in my scatter plot. So this is my scatter plot. I can now do second quit right here. If I do zoom 9 again, zoom 9, the line of best fit will draw on the scatter plot because I instructed my calculator to keep the line of best fit in Y1. So I push trace. If I push trace and arrow down, that is the equation right here, the equation I talked to you about. That is the equation. Okay, so that is example 1. That is example 1 on how to find the linear relation equation. How do I find the... so this is a linear regression analysis we just did. Okay, so you could be told to test the linear regression. What you're going to do is the correlation between drilling depth and time is 0.773. The critical value is for n equal to 2. 12 is 0.5957 since 0.773 is greater than 0.576, there is a positive linear relation between time and drill. That's it. So the critical value depends on n. The critical value. So what did I just say? Let's go and see it. Let's go and see it. You can be told to decide if there is a linear relation. Does the linear relation exist? So determine whether a linear relationship exists between the drill time and the fit. Okay, comment on the type of relation that appears to exist between the drill time. So we already talked about that, but let's go back and let's go to the table and see what they are saying. What are they actually saying? So let's see this table. The sample size is 12, and our answer was 77. So the sample size was 12 in that. So from here, we see that 12 is equal to 0.576. Okay, and that is from the table. This is from the table. But the calculated R is 0.775 because the calculated R is greater. 0.775 is greater than 0.576, we conclude there is a linear relationship because the calculated linear relationship, coefficient of correlation is greater. There is a linear relationship between the two variables. Okay, so that is what that question is asking you to do. It's asking you, can you use the table to say if there is a relationship between the two variables? Yes, there is a relationship between the two variables because the calculated R is greater than the one from the table. I hope you're going to read this. Okay, so another thing you want to talk about is what is called locking variable. What is called locking variable? In coefficient of correlation, another way that two variables can be related, even though there is not a causal relation, is through a locking variable. There could be a locking variable. A locking variable is something that exists, something like an outlier. It's exists in the data and is pulling the data down, okay, making it higher when actually, in actual fact, it's not. A locking variable is related to both the explanatory and the response variable. For example, ice cream sales and crime rates have a high positive relationship, but does this mean that local government should shut down all the ice cream shops? No. The locking variable is temperature. So the locking variable is temperature. As air temperature rises, both ice cream sales and crime rates increase. So that's a high positive relationship, and not because. So high relationship does not mean causation. That they are highly related does not mean causation. Okay, so we will go to chapter 5 and get another example. So let's go to chapter 5. So this is chapter 4, actually, not chapter 5. We are going to 4.2. So let's look into chapter 4.2. All right, so we just did 4.1. All right, so this is 4.1, which we have already talked about. Now let's go to 4.1 again. And by the way, this is the formula. This is the formula for R. We encourage you to calculate R with calculator, not by equation. We encourage you to use your calculator to calculate R. Okay, so don't use equation. All right, so I'm going to pick another example, and we do it, we find the coefficient of correlation. So we pick another example. And by the way, these are the properties of coefficient of correlation. We already talked about this. You want to make sure you know the properties of coefficient of correlation. Don't forget, you have to read this, make sure you know this. The properties of correlation, linear correlation coefficient. All these properties, you must know them. Okay, so I am going down to get another question which we can use to find coefficient of correlation. All right, so let me use this one. Finding an equation that describes linear relations. So I want us to look at this table here. Let's look at the table here. We are given this table right here, and we are told to only use 2 points. Choose 2 points and calculate. So remember, we already know how to find the equation of a line. Find the linear equation that relates to x, the explanatory variable, and y, the response variable. By selecting 2 points, find the equation of the equation containing the lines. So what you want to do, first of all, is find the slope of this equation. Find the slope. Remember, the slope, let me get my whiteboard. All right, so I am going to get this one too and make it smaller. That way I can write on both of them. Okay, so the slope is equal to y2 minus y1 over x2 minus x1. Okay, and then I'll go up to that point again. I'm going to the point given to me. And the points given to me are, the first point is 2, 5.7, 2, 5.7. So this is the first point. And I'll call this one x1, y1. And the next point given to me, the next point given to me is 6, 1.9, 6, 1.9. And I'll call this x2, y2. So now I'm ready to find the slope. So the slope connecting these 2 points is y2 minus y1. So y2 is 1.9 minus y1, 5.7, divided by x2 minus x1, divided by 6 minus 2. So let's simplify. We can do it with a calculator or just do it by hand. So if I already know that 5.7 is greater, and I'm subtracting, so the numerator is going to be negative. So 1.9 minus 5.7. So I have a negative in the numerator. So that is going to give me negative 3.8 right here. And in the denominator, 6 minus 2 is 4. So I'll go back to my calculator and ask it to find 3.8 divided by 4. I'm going to divide this by 4. Therefore, the slope is approximately negative 0.95. So this is the slope. Okay. Now that I have found the slope, I'm told to write this equation by hand, first of all. So I know the slope. I can use the point x1, y1 to find the equation. So to do that, I will use the point slope formula. Y minus y1 is equal to slope into x minus x1. Okay, and to do this, I am going to find y minus y1. What is y1 in the... So y1 is 5.7. 5.7. Slope is given to me as negative 0.95. And then x minus x1. Okay, x1 is 2. So now I can distribute into the parentheses so that I have equal to negative 0.95x minus minus is plus. I have plus 2 times 0.95 right now on the right hand side. Okay, and then I'll add plus 5.7 on both sides, plus 5.7, 5.7. And then I have, I'm just going to get my calculator, multiply out. So I have 2 multiply 0.95, and I have this. Then I add 5.7 plus 5.7, 5.7, and I have 7.6. Therefore, on the right-hand side, I can now rewrite this equation. So I'm going to rewrite the equation. Okay, so y is equal to, I am rewriting the equation so that it will look like slope-intercept form, plus I am going to get my calculator and plus 7.6. So this is the equation of the line choosing 2 points. But this equation may not actually be very, very correct. So now I'm going to do it with calculator. I'm going to do it calculator again. So let's get this data again. We're going to go back to the data and do it by calculator. So I'm going to make it large. Put my calculator again, and I'm clear. Go to start, clear L1 and L2, because I don't need this data anymore. Clear L1. All right, so the data I have right here starts from 0. So 0, enter 2, 3, 5, 6, 6. So I entered the data in the explanatory variable. Now data in response variable is 5.8, the first one. 5.8, 5.7 to 5.2, 2.8, 1.9, and 2.2. So we're going to do linear regression analysis again with this data. When we do the linear regression analysis, we get the equation, and we shall compare the two equations and see the one we did by hand and the one we did by calculator. Which one is better? Which one is more accurate? Okay, so let's calculate. First of all, let's do a scatter plot of this. So second scatter plot in 1. Select scatter plot, which is number 1, and I'm going to zoom 9 right now. Zoom 9. I'm going to my y equals and clearing this. Okay, so I'm zoom 9 again. Zoom 9. Okay, so the scatter plot actually looks like it has a negative linear relationship. Okay, it looks like the line of best fit will be negative. So I put a line on it. How do I put a line? Go to Stat, arrow to Calc, select number 4, which is linear regression. And then my data is in L1 and L2. I want to instruct my calculator to put the equation in Y1. So vars, Y-vars, function Y1, and then calculate. All right, so now I found the equation. Then I'm going to y equals, this is the equation. Well, the equation, let me pull up my the other equation, and then I pull up my calculator. You see, the equation right here is not exactly the same as that. So when I do it by hand, the equation will not be as accurate as the equation when I do it with calculator. We are comparing the equation we did by hand with 2 points and the one we did with linear regression, even though both of them have a negative linear relationship, but the one I did with my calculator is more accurate. So I can zoom 9. Let me zoom 9 so I can see this equation on the graph. So this is the equation on the graph now. So you can see it is more accurate than the other one. Okay. So this is more accurate than the other one. So we have done 2 examples of graphing a scatter plot and drawing the regression equation. Okay. And I will actually be told also to. So that is the kind of scatter plot I had before. And then I'll be told to find the residual. I want you to see the calculation, the formula for residual. The formula for residual is observed y minus predicted y. You must know how to calculate the residual. What do we actually mean by observed y? Okay, I'm going to go to bring the equation again. And so I bring the equation. This is, let's see how I get the equation. Now I'm going to pull it up. So I am told to find this is the equation right here. All right, if I'm told to find the regression for 2, then I will say the observed minus predicted. How did I know which one is observed and which one is predicted? The observed is the actual y value. The observed is the actual y value given to you, while the predicted is the equation that if I substitute 2 in the original equation, I will find the predicted. Okay, so let me find the residual right now. I want to find the residual for 2. So let me find the rest. This is how I do it. Let me get a, and then I'll minimize it. Find the residual for 2. That's what I'm trying to do now. If I'm told to find the residual for 2, what I'm going to do, residual is equal to observed y minus predicted y. What do I mean by observed y? I will just go to, let me get that. Let me go to, so for 2, the observed is 5.7. For 2, the actual y value is 5.7 minus predicted. How do I get the predicted? The predicted is going to give me the f of 2. What does f of 2 mean? Substitute 2 in the equation in y1. That's what it means. So I'm going to go to my y1 and ask my calculator, second quote. I will ask my calculator to substitute 2 in y1. So I'll say vars function y1, and then I will substitute 2 there. In other words, what is the value of y when x is 2 in that equation? What is the value of y when x is 2? So I got it here. My calculator told me it's 5.122. So I have 5.122. 5.122. So observed minus predicted. The observed is 5.7. I will get my calculator now and find the difference. So I'm going to subtract the predicted, which is 5.122. Therefore, okay, I'm going to do it again. 5.7 minus 5.122. Okay, so the residual is 0.578. Residual is 0.578. So since residual is 0.578, this point is above the line. The residual is the point on the line. Where is it? Is it above the line or below the line? For example, if I draw the scatter plot and this point above and this is below, above and below, the distance from here to here is called the residual. If I calculate the distance from here to here, it is going to be positive. If I find the residual for this point, and when I calculate, it's going to be negative. Therefore, since the residual is positive here, then we want to say that this point is above the line. When the residual is positive, the point is above the line. When the residual is negative, the point is below the line. When the residual is positive, point is above the line. When the residual is negative, point is above the line. Okay, we will talk about linear regression again on Tuesday before we get into distributions. By the way, we shall be talking about the chapter 5. From chapter 5, we have what we call the probability. So chapter 5, and it's going to be